Okay, so welcome to Lab 2. Once again, we are going to be working with opioid data that was part of the DEA's ARCOS database that tracks transactions of opioids, scheduled drugs. The Washington Post, again, recently released this data, or at least slices of it, to allow other journalists to track the spread of the opioid crisis and discover who was responsible for manufacturing, distributing, and then pharmacies in local communities giving away prescriptions or dispensing prescriptions of scheduled opioids. So in previous classes, we were working with aggregated data showing total number of pills between 2006 and 2012 in select West Virginia counties. So far, we've worked with Mingo County. Our last assignment was Logan County. And if you remember, we were previously downloading aggregated files. So things where not really working with the raw data, actually just working with the data that somebody else had done the hard work of computing on. So that's how we were able to know, for example, that in between 2006 and 2012 in Logan County, West Virginia, the Family Discount Pharmacy in Mount Gay received a total of 12.8 million pills. So this isn't the original form of the data. If you remember, here's the last spreadsheet from the last in-class assignment we did, where you had the total dosage unit, total number of pills, total records, total number of shipments to Family Discount Pharmacy in Mount Gay. This was aggregated information. This wasn't the way that the data originally came from in the data set that the Post got through the lawsuit. The journalists there actually had to do some work to aggregate or create these totals. So today we are actually going to start working with the raw data, or closer to a form of the raw data that was used to produce this analysis. And we're going to start by generating some similar things to what we've been working with previously. I'm going to show you how to take the raw data and produce a sheet very much like this, showing the number of pills for each pharmacy, or the number of pills distributed by each distributor to Logan County, or the number of pills distributed by or manufactured by each manufacturer that were ultimately sent to Logan County. So the first thing we're going to do is we're going to go back to the page where we've been getting the data from. If you're unable to do this download, I actually have a slice. This slice already downloaded in the course GitHub repo. So I've selected West Virginia, Logan County. And this time, instead of downloading the distributor data for Logan County, I'm going to download the raw data for Logan County. And that may take a second to pull down, so I may pause while that goes. And I'm going to choose to save the file and hit OK. Okay, it finished downloading. I went ahead and put it into a folder where I could find it. Just like the other data, this is a tab delimited file, meaning the columns are separated by tabs from each other in the data set. So we've got ARCOS, the name of the database, West Virginia, Logan, and then the state 54 FIPS code for West Virginia, 45 FIPS code for Logan County. Notice this is much bigger. This is 29.4 megabytes. The other ones were like 2 kilobytes, those smaller data that we've been working with. So this is data in a more original form, the kind of thing that you're really going to need to be able to work with some facility if you want to do sort of interesting investigative stories. All right, so I've created a Google spreadsheet for this lab. I've already created a source file for this. This is the Washington Post opioid ARCOS files. This is the date that it was pulled up. and just identifying sort of what it is. So just like before, I'm going to go to File, New, Spreadsheet, no, not New Spreadsheet, sorry, File, Import, and click on Upload and select a file from my device. And I'm just going to go into the repo I've created for this folder. This will be somewhere on your desktop, I imagine. And here's the tab separated value file, and I'm going to go ahead and open that up. It's going to take a second to upload. So again, I want to insert it into a new sheet, and it's tab delimited, so not separated by commas or something else, but tabs. And yes, we want to convert text to numbers, dates, and formulas. So that's going to take a second to load up, so I'm going to pause. Okay, so we're back. This took a little while to load up. You probably noticed your browser may have crashed. You may have had to refresh. A data set this large, generally it's not something I'm going to want to be working in Google Sheets with. Ultimately, this is something, this kind of raw data, that's better suited for something like R or Python. And we're going to be learning a lot of those later in the semester. But for now, I just want to be able to show you one really powerful, or a few really powerful features of Google Sheets. So here's the data. You will notice, one, there's a lot more columns, and we'll go through and describe those. Two, 65,360 rows, which is a whole lot more than we have previously worked with. And so I just want to sort of run through these one by one. So the first is our header field. So some new columns here, and I'm going to provide a link to the documentation for this data. So we basically have one record describing one shipment of one type of drug, and it's tracking its path in this data from distributor. This is the distributor to the pharmacy, or in some cases practitioners. Produced by one company. So this first record here, let's just go through this, describes a shipment from a distributor called Cedardale Distributors in Gotham, New Jersey, to a retail pharmacy called Family Discount Pharmacy on Mount Gay Road in Mount Gay, West Virginia, in Logan County. These were shipments of hydrocodone, quantity of 4, 2,000 dosage units, which we've been using as a substitute for pills, again, of hydrocodone, produced by Activist Pharma in Cedardale, again, distributed by Cedardale, which is also repeated over. There's also some information on dosage strength. Okay, so again, this is data in its more raw form. And the first thing I want to show you all is a tool for making large data sets like this more manageable. And that's a thing called filtering. So filtering is a way of taking the entirety of the data set. So in this case, we have 65,000 records across something like 30 different columns, describing multiple shipments from different pharmaceutical companies to through distributors, through to pharmacies. We've got detail on hydrocodone and oxycodone. So filtering is a way of creating subsets in the data. So this is a technique we're going to do a lot, not just in Google Sheets, but also when we get to R. So in Sheets, the first thing we do is go to Data and click Create a Filter. And this may take a second because this is a very large data set. So you will notice here, I'm just going to make this a little bit bigger. You'll notice here that now in our header row, we've got these little green triangles, and when I mouse over them, things happen. So it's helpful to have a question in mind when we're starting to do this. So maybe one of our first questions would be, I'd really like to just work with the subset of records that went to the family discount pharmacy. So I'm going to come over to this buyer name column, and I'm going to click this little button here. And you'll notice, and these probably look familiar from our last assignment, the names of places in Logan County where drugs were shipped. So I'm going to select just the family discount pharmacy. So the first thing I'm going to do is I'm going to hit this clear button, and then I'm going to select family discount PHCY of Stolings, or I'm going to select Family Discount Pharmacy Inc. So I'm going to start by selecting Family Discount Pharmacy Inc. Okay. So this returns a subset of all of the records in the data that were shipped to Family Discount Pharmacy Inc. We can also apply multiple filters at once. So let's suppose we only wanted to look at the subset of data where that were shipped to Family Discount Pharmacy Inc. By one particular distributor. And in that case, the distributor we're going to go with is Miami Lucan. So I'm going to hit clear here. Select Miami Lucan. Okay. So if we had some reason to think that there was something interesting or possibly suspicious about shipments from Miami Lucan to the Family Discount Pharmacy, this would allow us to see the approximately 12 or so records where that happened. So again, keeping in mind each of these is a single shipment. So in this case, let's say we only wanted to look for shipments of oxycodone. Maybe a source has told you that there was something questionable about this is a shipment of oxycodone by Miami Lucan to Family Discount Pharmacy. So in this case, I'm going to go over to drug name and filter. And now we have exactly one left. Okay, so we're going to go ahead and turn all the filters off. One quick way to do that would just be to come in here. Each one we selected, so hit select all. We know a filter's on when when the little 3 green triangles turn into more of a, looks like a funnel, it's a filter. Select all. And let's see if we've got buyer name on. Select all. Another thing you could do is just click this button to turn off the filter, and then click it again to turn it back on. Okay, so in addition to filtering for specific things, we can also filter based on sort of mathematical formulas. So let's say I wanted to only look at individual shipments of like extremely large quantities. So if we look in this dosage unit category, we can see that there were some shipments of as many as like 25,000. Maybe I'm curious about that. A thing I can do is do filter by value or filter by condition and select greater than. So let's say we only want to look at greater than 20,000 in this case, and I'll hit OK. So this is the sort of really big shipments here. In this case, there were 3 shipments to the Family Discount Pharmacy in Mount Gay of 22,000, 25,000, and 22,500. And then 1 shipment, and those were all those were from the McKesson Corporation and from Cedardale. And then there was another one, the Aracoma Drug Company of Chapmanville, according to this data. Shipments of hydrocodone. So we can learn quite a lot about each of these things this way. So there's greater than. We can also filter by text values. So I'm just going to turn this off here to reselect everything. So let's say that we want to look at all of the pharmacies that are on Main Street or people who are on Main Street. Maybe through a bit of storytelling, we want to look at this one street that everybody in town knows about to give people a frame of reference to understand the scope of pill shipments. So I can select buyer address. And again, I'm going to filter by condition. And got a bunch of things here, right? So text contains, text does not contain, text starts with. If I do text contain, I can search for Main. Hit OK. And now it's pulling up all the shipments on Main Street. If I instead did starts with Main, notice I'm not now picking things up that started with like the address number, right? So what you filter on is important here. Empty cells. So this is actually kind of useful for like data cleaning exercises. If you wanted to look at all of the cases where the buyer's address was empty for some reason, that may be suspicious, maybe not. Nothing really there. There's also text does not contain. So let's say we wanted to look for everything not on Main Street. Now we're getting a bunch of PO boxes. We're also getting a lot of null values, which is interesting. That's different than missing, though functionally they often mean the same thing, but there actually is text there to search for. So there's a lot you can do with filters. We're just kind of scratching the surface here, but they're a really useful way to create subsets of your data. Okay, so next we're going to go over pivot tables. One thing I forgot to mention at the top that you should be doing when you set up your sheet. I'm just going to walk through that now. First thing is it's just useful to freeze the top row. There's also a bunch of checks, and we're going to go through this sort of later in the semester, but when you're working with a brand new data set, especially a raw data set this large, there are a lot of things that you're going to want to look for that could cause problems if they're not identified down the road, like missing values or inconsistent naming conventions. We're going to go through a lot of that later in the course. For now, I just really want to dig in and get us going on some of the analysis. But just keep in mind that's something we're going to be doing later. I'd already created the source tab, but I'm also going to insert a column just called rec number and 1 and 2, and just double click to fill it down. So now we can go back and sort it the original way if we needed to. Okay, so now we're going to create pivot tables, and I think probably the best way of describing what pivot tables do is that they take large data sets, not always very large, but large data sets, and allow you to group like things together and summarize what you find. So we've already been sort of working with what I would consider to be the output of a pivot table, so I just want to show you that. So again, remember, this is the raw data in which there is, or close to a raw data form, in which there is one record describing one shipment, describing the chain that goes from drug manufacturer to distributor to pharmacy. There's details about the pills that were sent, how many, what kind, what strength, all sorts of things here. Previous to this, we've been working with this. I'm pulling up the assignment we did in class the other day, which is very different. Like, so this right here is the list of pharmacies in Logan, and pharmacy is sort of a more general name for like people who bought. So in some cases there are doctors and other pain management specialists and things on here. They're not all physical pharmacies. But there's one record per pharmacy, which shows between 2006 and 2012 exactly how many total dosage units, pills, how many total record shipments were sent to this pharmacy over that period. There's only 29 rows here. This is aggregated data. So while it's unlikely that the journalists who produced this at the Post did this taking the data that we're working with here and made a pivot table to produce this and get this to you, they likely used a much more some sort of data programming language to do this work, or to automate a lot of it. In this case, we're going to use a pivot table to essentially take this raw data for Logan County and make a group all of the transactions by individual buyers and then get the output of this dosage unit. So essentially, pivot tables allow us to take this huge monster 65,000 record raw data set and turn it into something closer to this easier to work with 30 record data set. Okay, so the first thing I'm going to do is go to data, the data tab, and click pivot table. And it's going to ask me where I want to put it, new sheet or an existing sheet. I highly recommend always putting it in a new sheet. Some people like putting multiple pivot tables in a separate sheet, but I just think it's easier to kind of create a new tab each time. So we're going to create this, and I'm going to call this pharmacy dosage units by pharmacy. Okay. All right, so this is where the pivot table is going to output when I summarize and sort of put things together. And this is the pivot table editor. This is the little graphical user interface that's going to allow me to build some things. So again, my goal here is to create one column with the name of the buyer, the pharmacy, one column with total dosage units. So just this column and this column to start, and then we're going to add some stuff here. So the rows, I'm going to click the add button, and I'm going to select buyer name, and we'll sort that ascending for now. And then, so what does that do? It took a second because this is a big spreadsheet, but you know, instead of 65,000 records, it basically pulls out each time there is a, you know, it takes all of the, you know, many hundreds of entries for Family Discount Pharmacy and groups them together just as one line. So this is aggregation or summarization. Okay, so now we need to tell it what to put here in this column next to it. And the thing we want it to say is total dosage units. Remember, we're trying to create this here, right? So what I'm looking for is to get the number 12,849,040 here next to Family Discount Pharmacy. So for values, I'm going to hit add. And we're going to select dosage units. Okay, and we'll just give it a second to pull up here. Okay. And I also want to sort this highest to lowest so we can see. So I'm going to come back here, select descending, highest to lowest. And then I'm going to select sum of dosage unit. Okay. Okay. So it's sorted. So we see Family Discount Pharmacy on the top, 12,849,040. 12,849,040. Next one on our list, Pharmacy Inc. 7,032,640. 7,032,640. I can highlight these to make them, or format them just to make them a little bit prettier. Okay. So one thing you'll notice that's a little bit different about our list, if we're comparing, is this Rite Aid of West Virginia, Inc. has 5,928,970. Whereas there's 4 Rite Aids of West Virginia, Inc., none of which have that many, right? This is the sheet that we got directly from the Post. 178,930, 143,020. So we have different values. This actually represents the sum of these 4 things here. Okay. So how do we get this to match up sort of apples to apples? Well, we can group by not just the buyer name, but also the town. So I'm going to add another row, and I'm going to go to buyer city, and we're going to give that a second to update here. It's going to take just a minute. Okay, and now you can see we've got this Rite Aid of West Virginia, right? It's got 4 cities underneath of it. There's one Rite Aid in Chapmanville, one in Logan, one in Man, and one in Mount Gay. So what we're doing here is something called grouping by, and in the R programming language that we'll work with for more in the semester, that's a very common thing we'll be doing. So grouping by, and then taking, say, the sum. And you'll notice each of these cities have, or each of these other people in the data people or pharmacies only have one city. So with the pivot table, what's happening here is Family Discount Pharmacy, Mount Gay, you've got the sum of 12,849,000. The total's repeated here. With this West Virginia, Rite Aid of West Virginia, here's the value for each separate store in different cities, and then here's the total there. So in addition to sum, we can do all kinds of aggregation here. So here are a few of the different things we can do. So we can count. So I'm going to change this to count. And that will take just 1 second to load up. Okay. And then I'm going to sort descending by count of dosage. Okay, so this serves essentially as a function of a count of records. So here's this Family Discount Pharmacy, 5680. Here's Family Discount Pharmacy back in the aggregate data we were working with yesterday, 5680. So counting would give us the number of records. Sum on dosage unit would give us the number of pills. So I'm just going to run that back one more time. So again, Family Discount Pharmacies at the top. We can also do average. So in this case, in the previous lab, I asked you a question, what was the average number of pills per order? And a thing we noticed was that the average shipment size to Family Discount Pharmacy of 2262 was much, much higher than any other anybody else in the entire county. This is the average for the entire county, 700 pills per shipment. Family Discount Pharmacy was up at 2262, so something sort of popped out there. We can also do min and max, so we can look at the largest shipment to each buyer. So I'm just going to select max there and give that a second to run. Remember, this is a big data set. All right, so Family Discount Pharmacy had a shipment of 25,000. That was the biggest. There's this Arcoma Drug Company had a shipment of 22.5. Everybody else was sort of much smaller, and we can see that we get some totals down here. So this is the maximum shipment to any size to any one pharmacy, and that was Family Discount Pharmacy. We can also create like a nice little summary table, so we're not limited to just like one computed column here. So let's say I wanted to do sum there. And let's say I wanted to add another one based on dosage unit, and I wanted to do count. So in a second, that adds another column. And just give it a second, it'll change to count. And I can add another column that has the average. And I can add another column on dosage unit that has the max. And if this doesn't bog down Excel too much, or Sheets, I'm also going to add min. which gives us a nice little look at how many shipments, how many pills, average pills per shipment, what was their biggest shipment, and what was their smallest shipment. So that's a pretty nice way of doing this. Okay, I'm also going to show you how we can do filters. So I'm going to click Add here, and let's say I really, I'm a very hyper-local reporter, and I only care about the pharmacies in Chapmanville, say. So I can clear all these, just select Chapmanville, hit OK. And any second now, here's our little run bar. Now it's only giving me the totals in Chapmanville. Notice it's changed the totals here too, right? So the computed totals are not for the whole data set, but they're for the filtered data set. Okay, I'm also going to show you how we can create like a little matrix or a grid. So let's say that we really wanted to look at just the pharmacies. Sorry, let's say we just wanted to look at dosage units. So I'm going to clear out the sum of dosage units. So total pills, I'm going to clear all that stuff out. I'm going to get rid of this filter. We're going to get everybody back up. And instead of putting buyer city in the row heading, I'm going to put it under column here, and let's take a look at what happens there. Okay, so what this is doing is it's essentially created a grid. So the row here is the name of the pharmacy. The columns are the name of cities in the county, and then it shows how many pills total went to that city from that pharmacy. So we can see that Family Discount Pharmacy is only in Mount Gay. In the Rite Aid of West Virginia actually has one in each of the 4 cities. There's nobody else that has sort of duplicates, so they're all broken apart here. The data hasn't yet been cleaned, and we'll do that in a subsequent lesson, probably when we get to R, where we can actually break down transactions by year, and we could have like 2006, 7, 8, 9, 10, 11, 12 up here with a total. So you can look at how things change over time. There's not really anything great yet in the way the data set is currently structured that would make it easy to show you how this works. I just want you to be aware that it's something you can do. Okay, so at this point, what I'd like you to do is go ahead and pause the video, and I would like you to create 3 pivot tables of your own. You're going to create a brand new tab for each pivot table, and all of your pivot tables, it can be whatever you want to look at and explore the data. It would be totally fine to me if you wanted to set out to recreate the distributor data from the class assignment we did in the last class assignment, where you do total dosage units for each distributor. You could do one for the manufacturer. You could create a nice little summary table kind of like this. But again, what I want you to do is get practice with using the raw data to create something. Or you could pull out something kind of on your own. You could look at how shipments for hydrocodone and oxycodone differed to different pharmacies. You could look at how the dosage units broke down. What were the, group these into buckets, group all the 2,000 things together, the 1,000 things together, the 50, the 100 together. You could break things down by town to look at how shipments to each town differed. You could break things down by shipments to chain pharmacies versus retail pharmacies. A lot of people have done stories on that. All those could be potentially interesting. But go ahead and create those three things, and that's the link you're gonna turn in the link at the end, and it should have that. So I'm gonna pause while you do that.